Hello my dear students, hope everybody are fine. Today I came in front of you with one more interesting and important topic, that is chemical equations and reactions in chemistry. Before I am entering into the topic, hope all the videos which I am making are reaching you and they are helping you to understand the topics better. The similar way, if you want some more students to get better understanding, please subscribe the channel, like the video and share it to your friends so that some more students also they try to understand the topic. Let us enter into today's topic. Today's topic is chemical equations and reactions. In that, first we will discuss what is a chemical reaction. What is a chemical reaction? When one or more substances combine together or react together and then form one more or some new products, some more substances which are having completely different properties will be called as a chemical reaction. So what happens here? One or more substances, they involve in some process and they form new substances which are having completely different chemical properties. So this will be called as a chemical reaction. Then how do we identify that chemical reaction has been taken place? Chemical reaction can be identified by observing these things. What we have to observe, is there any gas evolved? Is there any gas evolved after the reaction? Then is there any change in the color? Or is there any change in the state? State means what? Physical state. Solid, liquid, aqueous, gas. Is there any change in the state? And is there any change in the temperature? And is there any precipitate form? So by observing these things, we can decide whether chemical reaction has been taken place or not. What you have to observe, is there any change in color? Color is changed or state is changed, or temperature increased or decreased, or is there any precipitate is formed? Precipitate means what? An insoluble substance which cannot be solved, which reaches the bottom of the container, that will be called as a precipitate. Is that formed? Or gas, we all know gas, it goes upwards. So these, if any one of these changes are taken place, we can say that chemical reaction has been taken place. Then after that we have to discuss this chemical reaction, how do we represent in symbolic form. The representation of chemical reaction in symbolic form, we call it as chemical equation. Let us take one example. I am taking one example here. When sodium reacts, generally we explain that reaction about in words, that when with one example I wanted to tell you. When sodium reacts with water, sodium hydroxide and hydrogen gas is evolved. This is the chemical reaction. When sodium reacts with water, sodium hydroxide and water is formed. So this information should be represented in the form of equation. So we have all symbols. For sodium we use Na, and water, how do we represent water? H2O. What is the molecular formula of water? H2O gives rise to, what is forming here? Sodium hydroxide. Sodium hydroxide is NaOH plus hydrogen gas is released. So H2. I wrote like this. So what this indicates, here I kept one arrow mark. What that arrow mark indicates? The process, the reaction process. And before the arrow marks, whatever we have substances, we call these substances as reactants because they are participating in the reaction. Substances which are participating in the reaction are called reactants. I wrote spelling wrong. Reactants. So these are what? These two are reactants which are participating in the reaction. After the reaction, what are formed? Sodium hydroxide and hydrogen gas is formed. So these two we call them products. So substances which are involving in the reaction will be called as reactants, and which are formed after the reaction will be called as products. Substances which are reactants, reactant substances will be written left side of the arrow mark and the products will be written right side of the arrow mark. So this symbolic representation of chemical reaction will be called as chemical equation. And here we also represent their states. solid, here this is liquid, and this is again solid, and this is what, gas. So this representation of chemical equation, chemical reaction will be called as chemical reaction. We discussed about what is a chemical reaction, chemical equation, and how do we identify chemical reaction is taken place or not. Now the next important topic is what, law of conservation of mass. What is law of conservation of mass? Already you studied law of conservation of energy. Law of conservation of energy means what, energy can neither be created nor be destroyed, but it can be transformed from one form to another form. It cannot be created or cannot be destroyed. The same way, mass also cannot be created or cannot be destroyed. When a chemical process is taken place, in that chemical process, no new mass will be created, or that existing mass cannot be destroyed. Before the reaction, whatever mass is there, after the reaction also, the mass, whole mass will be same. So that is what, law of conservation of mass. So to have that mass same before the reaction and after the reaction, we need to balance the equations. If you observe the equation carefully, which I have written above, you can see here one sodium atom, these two are balanced, same. One oxygen atom, here one oxygen atom, oxygens are also okay. But when you see hydrogens, here two hydrogens are there, here three hydrogens are there. Hydrogens are different. So mass in products will be same, here mass will be less because their hydrogen atoms are more. So we should have same mass before the reaction and after the reaction. So to have that equal mass, we need to balance the equation. So to balance that equation, you observe first what all different types of atoms we have in the reaction. We have sodium, hydrogen and oxygen. So if you see sodium, we have reactant side 1, product side also 1, sodium. Then hydrogen, we have reactant side 2, but product side 3. Oxygens we have same 1, 1. So what are different here? Hydrogens are different, we need to balance hydrogens. So for that, what I am writing this equation as Na as it is plus H2O as it is, but here I am writing 2NaOH. So that what happens? Now this number will become, I am changing this number now. Now sodiums are different. Sodiums are changed. Sodium reactant side 1 we have, but product side 2 we have. Then hydrogens. Hydrogens we have reactant side 2, but product side here 2 and here 2, 4. Now oxygens, reactant side 1, but product side 2. Like this we have. So again, what are different now? Sodium is different, oxygen is different, both are different. So to balance this, what we have to do? Next process, I am writing 2Na so that sodiums will be 2 times and 2H2O also. Now if we observe, both the sides, it will be same number of atoms. See here, sodiums will be, once observe all the atoms, number of atoms. Sodiums we have 2 here, reactant side, product side also 2 we have. And hydrogens we have 4 here, here 2 plus 2, 4, so 4. And oxygens we have 2 here, even product side also 2. So like this, same number of atoms we will be having reactant side and product side, so that whole mass in reactant side and product side will be equal. So in this way, we need to balance the chemical equations, one of the important topic. Now the next topic is, what are the different types of chemical reactions we have? In that first one is what? Combination reaction. It's very simple. If 2 or more substances combine together to form a single product, means what? Reactants should be more, but product should be single. So before arrow you should have more, you can have many, but after arrow you should have only one, so that we say that it is a combination reaction. I will tell you one example. C plus O2, very simple example I am telling you. C plus O2 gives rise to CO2. Here what happened? Carbon and oxygen together carbon and oxygen combine together to form carbon dioxide. We have single product. You remember, to decide it is a combination reaction, you need to check only single product is there or not. If single product is there, you can decide it is a combination reaction. Hope you all understood this combination reaction. What is decomposition reaction? Decomposition reaction means what? In name itself it is there, it will be decomposed. Means what? Single reactant will be there, many products will be there, opposite to the combination. In combination, many reactants, single product. In decomposition, single reactant, many products. Here we have different types of decompositions. These decompositions depends on the type of energy. So what decomposition? I told you decomposition means what? A single reactant will be divided into many products. So to divide that substance we need some energy. Okay, to divide the given substance into many products we need energy. Depends on energy which is utilized in the reaction, we call which type of reaction it is. We classify which type of reaction it is. So what is decomposition? Single reactant, many products. You keep that in mind. Now let us discuss about thermal decomposition. If you use heat energy to decompose the substance, then the reaction will be called as thermal decomposition. If heat energy is used for decomposition, then the reaction will be called as thermal decomposition. For example, there is calcium carbonate, CaCO3 is decomposed by heating. By heating what? That symbol indicates heat energy. Heat is absorbed or heat is utilized. So by using heat, CaCO3 is decomposed as CaO plus CO2. This is what? Example of thermal decomposition. Many examples are there. To understand, I am telling you one example. Single substance is decomposed into many by using heat. So that is what? Thermal decomposition. Next we have photolytic decomposition. Photolytic decomposition means what? Here instead of heat energy, we use light energy. If by using light energy, if you decompose the substance, we call it as thermal decomposition. We have this example 2AgCl2, silver chloride. 2AgCl, if you keep in light, what happens? It will be decomposed as 2Ag plus Cl2. So here what happens? It is used in black and white photography. When you read about one reaction, you try to know their uses also, application also, so that it will help you to answer all the type of MCQs. So it is what? Silver chloride is converted into silver and chlorine. It is decomposed. So this is what? One more example in which presence of sunlight means what? Here light energy is used. Next one we have electrolytic decomposition. What is electrolytic decomposition? Here not only 2AgCl, one more example also we have 2AgBr, silver bromide. These two are used in black and white photography. 2AgBr2. Both are examples of photolytic decomposition. Now electrolytic decomposition. What happens here? Electrolysis process. Hope everybody remember. By using electrolysis process, we pass electricity through the substance so that that substance will be decomposed as ions. It will be decomposed into ions. For example, we pass electricity through water, so that what happens? H2O, water, will be decomposed as hydrogen ions and oxygen ions. That is, water will be decomposed as hydrogen and oxygen gases. This is by using electric energy, current. So what we call it as electrolytic decomposition. Hope you all understood. First one, combination reaction, two or more combine together to form single. Second one will be decomposed into many, but we use different types of energy, heat energy, light energy and the electricity. So if you use heat energy, it is thermal decomposition, light energy, photolytic decomposition, electricity, electrolytic decomposition. you should know how to identify which energy you are using to decompose. Based on that we decide. So this is about decomposition reaction. Now coming to displacement reaction. Here, to know about displacement reaction, you have to know metallic reactivity series of metals. We will discuss about that later. But what is displacement reaction? In displacement reaction, what happens? One metal displaces another metal. One high reactive metal displaces the low reactive metal from the compound. For example, we will take here Fe is high reactive metal, then copper salt, CaSO4 is the salt. Now after the reaction what happens? Here, because iron is more reactive than copper, iron displaces copper. So iron will be combined with sulfate, copper will be sent away. So what here, after the reaction what happens? It will become FeSO4 plus Cu. So what happened here? Iron is replacing copper because iron is more reactive than copper. You can see here in the reaction series we have barium, calcium, magnesium, aluminum, zinc, iron, then where we have copper down, low reactive. So what? High reactive metals replaces low reactive metals. If it comes in opposite way, for example in some cases what it will be given, like this question will be given, Cu plus FeSO4 gives rise to what? Write the products. If it is given here like this, what you can write? If it is given like this, what are the products? Then you can write FeSO4 plus Cu, because Fe is more reactive than Cu. Iron is more reactive than copper. But here copper cannot displace iron because copper is low reactive. So what you have to write here? No reaction. No reaction will be taken place. So this based on what? It depends on reactivity series. You try to remember which are high reactive, which are low reactive. Depends on hydrogen. All the metals above the hydrogen we take them as high reactive and the below them low reactive. Not only that, even potassium, sodium, if you take, sodium cannot replace potassium because potassium is more reactive than sodium. So that is what displacement reaction. In displacement reaction what happens? One metal will be displaced by another metal. This is displacement reaction. Now double displacement reaction. In double displacement reaction what happens? You will be having two salts which are the combinations of cations and anions. Both the ions will be interchanged. So double displacement reaction is nothing but it is the mutual exchange of ions. By one example you can understand better. There are two salts, Na2SO4 and another is BeCl2, barium chloride, sodium sulfate plus barium chloride. After the reaction what happens? Here this is cation and this is anion, this is again cation, this is anion. So what happens? This sodium combines with chlorine and this sulfate combines with barium. Both the ions will be exchanged. Barium, I wrote BeCl2, it is barium chloride, not it is BaCl2. BaCl2. Beryllium, I wrote beryllium chloride, barium chloride it is. So what happens here? Both the ions will be exchanged. So I am writing again. So I am taking two salts, Na2SO4 plus BaCl2 gives rise to barium chloride, gives rise to what happens here? Barium will combine with sulfate, BaSO4, and sodium will combine with chlorine. So here two sodiums we have, two chlorines we have, that's why it is 2NaCl. So here like this both the ions will be exchanged. When two ions are exchanged then double displacement reaction will be taken place. Here this is insoluble substance. So what we call it? We call it as precipitate, and it is white precipitate in this case. A white precipitate will be formed in this reaction. Generally, whenever there is mutual exchange of ions, a precipitate will be formed, and the reaction will also be called as precipitation reaction. Try to remember, whenever mutual exchange of ions taken place, precipitate will be formed. The double displacement reaction, it will happen. So double displacement reaction is also a precipitation reaction. Hope you all understood about this. Now coming to next one, we have exothermic, endothermic. In name itself we have exo means what? In which it comes out, energy comes out. In a reaction, in any chemical reaction, if energy is released, then that reaction will be called as exothermic reaction. For example, when calcium oxide quicklime reacts with water, what happens? It vigorously reacts, highly reacts with water, and it forms slaked lime, CaOH taken twice, and along with calcium hydroxide, heat also it will be released. So what is happening in this reaction? When calcium oxide quicklime is reacting with water, calcium hydroxide is formed along with heat. So what is happening here? Heat is releasing, energy is released. Then the reaction will be called as exothermic reaction. You have to understand, you have to remember, whenever energy, whatever energy, generally heat energy, any energy when it is released, we call it as exothermic reaction. For example, we have one more in biology, respiration. Respiration also comes under exothermic reaction. And one more also, acid, dilution of acid. When you are diluting acid, heat will be highly exothermic, it is, heat will be released. So what? That is also exothermic reaction. You try to remember, dilution of acid, and this one slaked lime, formation of slaked lime from quicklime, and one more respiration. All these are what? Exothermic reactions, because heat is released in all these cases. Now coming to endothermic reaction, it is opposite to that. Here what happens? Heat will be absorbed or utilized. For example, we have seen before, CaCO3 can be taken for the example of CaCO3 can be taken for example of endothermic, because here we are using heat energy. CaCO3 gives rise to CaO plus CO2. Here what happened? Heat is absorbed, energy is absorbed. So what we call it? Endothermic reaction. This is one endothermic reaction. Even photosynthesis also we call endothermic reaction, because their sunlight, energy is used, energy is absorbed. So these are some examples of endothermic and exothermic reactions. So coming to oxidation, important. Here what happens in oxidation? Three things you have to remember. One is oxygen is added. If oxygen is added to the substance, or hydrogen is removed. Hydrogen is removed from the substance, or electrons are removed. If electrons are removed, in these three cases, if these three are taken place in any chemical reaction, then we call it as oxidation reaction. For example, one example I will tell you, C plus O2, first one we have written, C plus O2 gives rise to CO2, oxygen is added. So we call it as oxidation reaction. Sometimes hydrogen will be removed. If hydrogen is removed, in that case also we call it as oxidation reaction only. One more I will tell you, for electrons removed, Zn gives rise to Zn2 plus 2 electrons. Here, because electrons are removed from zinc after the reaction, we call that also oxidation reaction. One more example, whenever hydrogen is removed also we call it as oxidation reaction only. So you remember, oxygen should be added, hydrogen should be removed, electron should be removed. We call, in that case we call it as oxidation reaction. Now reduction reaction. In reduction reaction what happens? oxygen should be removed or hydrogen should be added, opposite, completely opposite, and electrons are added, then we call it as what? Reduction reaction. For example, we have sodium 2Na plus H2 gives rise to 2NaH. In this case, what is happening? Hydrogen is added to the substance, so that we can call it as reduction reaction. Similarly, we can also write Zn2 plus 2 electrons. Here 2 electrons are added, so that we can say that it is reduction reaction. Redox reaction. Redox reaction means what? In single chemical reaction, oxidation should be done and reduction should be done. If these two are done in a single chemical reaction, we call it as redox reaction. Now let us see one example. I have CuO plus H2 gives rise to Cu plus H2O. What is happening here? Copper oxide and hydrogen combine together to form again copper and H2O. Here what happened? If you see this copper oxide, after the reaction, what happened here? Only copper. So what happened here? In this case, reduction was taken place because oxygen is removed. Reduction. In the same reaction, here down if you see, before it is hydrogen, but after the reaction, oxygen is added. So what we call it? Oxidation. So in single chemical reaction, both are happened. Oxygen is removed and oxygen is added. Because oxygen is removed, we call it as reduction, and because oxygen is added, we call it as oxidation. Here one important point we need to remember in redox reaction, that is how to identify which substance got oxidized, which substance got reduced. In this example, if you see which substance got oxidized, which substance got reduced, every time in every exam one question is coming in this. Now let us see. I am erasing all this to understand better. Redox reaction. So I wrote example CuO plus H2 gives rise to Cu plus H2O. In this, what happened here? Here what happened in this case? Reduction happened because oxygen is removed. Here what happened? Oxidation. They asked which substance got oxidized, which substance got reduced. Substance which got oxidized or substance which got reduced, both will be on reactant side only, not from product side. So in options, multiple choice questions, they will give you options. So product side options you should not select, because oxidized substance or reduced substance, both will be there towards left side only, reactant side only. So now we have to decide which got oxidized, which got reduced. If you see carefully, in CuO, before the reaction oxygen is there, after the reaction oxygen is not there, oxygen is removed. So what happened? CuO. What happened to CuO? CuO is reduced because oxygen is removed. You have to keep those points in mind, where oxygen is removed or hydrogen is added, is oxidized. Where oxygen is added, oxygen is removed or hydrogen is, let me say again, repeat again. If oxygen is added or hydrogen is removed, that will be oxidized. If oxygen is removed and hydrogen is added, that will be reduced. So remember, so here CuO, oxygen is removed, so we call it as reduced, and hydrogen In hydrogen, for hydrogen it is oxygen added, so what we call it, oxidized. This is okay. And they also ask you about oxidizing agent and reducing agent. Substance which got oxidized, substance which got reduced. Oxidizing agent, reducing agent. What is oxidizing agent? Which helps for oxidation. Reducing agent which helps for reduction. Here it is opposite. Agents will be opposite. Substance which got reduced behaves as oxidizing agent. So CuO got reduced. So CuO is what? Oxidizing agent. First you have to decide which is oxidized, which is reduced. Once you decided, the substance which got reduced is oxidizing agent. You remember this. And substance which got reduced, oxidized. Substance which got oxidized is reducing agent. So first what you have to identify, which substance got oxidized, which substance got reduced. Both will be there, reactant side. Then you have to take opposite. Substance which got oxidized is reducing agent. Substance which got reduced is oxidizing agent. So these are some very important concepts